Hello, my name is Ray. I'm the Ray in the Ray code. In this video, I'll be covering the adapter design pattern, and I'll be using C#, not C++, but C#. Although I do tutorials in C++ and other programming languages, this video will be in C#. I use this programming language to cover this design pattern and also the other design patterns. You can tell your friends, put me on your cover letter, resume, voicemail, social media, wherever you can publicize me. I understand this is the optimal way to go viral. I have put timestamps in the margin so you can navigate to the section you desire most. My favorite is the SWOT analysis. Please like this video, leave a comment, and subscribe. The Ray Code can be found on many social media platforms. Please search them out and become a Ray Code groupie. Let's discuss the adapter pattern and its relevance to C# programmers. Adapter design pattern. The adapter design pattern, often known as the wrapper, falls under the structural design pattern category. Its primary intent is to bridge the gap between two incompatible interfaces. Essentially, this pattern involves creating a new interface, the adapter, that allows an existing class to work with other classes without modifying the source code. Why should C# programmers study the adapter design pattern? Integrate legacy systems. In enterprise environments, there's often a need to integrate legacy systems with newer systems. The adapter pattern provides a mechanism to make old systems work with new ones without having to make widespread changes. Promote code reusability. C# developers might have libraries or components with functionalities that are essential but need to match the required system interface. Instead of rewriting, they can adapt the existing component, promoting reusability. Enhance modularity. The adapter pattern promotes separation of concerns by ensuring that functionality and interface adaptation are separate. This results in a more modular and maintainable codebase. Expand third-party libraries compatibility. Often, third-party libraries or components come with their own interface that might not fit seamlessly into your application. Adapters can be used to mold these components into shapes that fit your system's requirements. Flexible system evolution. As systems evolve, newer interfaces or ways of doing things emerge. The adapter pattern allows developers to smoothly transition or incorporate new functionalities without disturbing existing workflows. Open-close principle. The adapter pattern aligns well with the open-close principle, one of the solid principles, which states that software entities should be open for extension but closed for modification. Using adapters, new behavior can be introduced without altering existing code. Simplify complex interfaces. Sometimes interfaces can be complicated and challenging to work with. An adapter can simplify these interfaces by providing a more convenient or streamlined way to interact with them, making it easier for other parts of the application to use. Multiple adapters. For a single interface, multiple adapters can be designed to make it compatible with multiple systems. This provides flexibility in how an interface interacts with other parts of a system. In context of C# with its rich standard library and extensive ecosystem of third-party components, understanding the adapter design pattern becomes crucial. It offers a structured approach to ensure components and systems work in harmony, fostering integration, modularity, and maintainability. By mastering this pattern, C# developers can build adaptable and resilient software. Structural pattern adapter for C# students. Target defines the interface the client expects to use, represents the standard way objects should behave, used directly by the client. Client works with objects through the target interface, does not know about the adaptee's interface, uses the adapter to interact with the adaptee. Adaptee has an existing interface that is compatible with target, contains useful behavior the client needs, cannot be changed easily. Adapter implements target interface. Translates client's request into adaptee calls. Connects incompatible interfaces safely. Hello, my name is Ray, and I'm the Ray in the Ray code. In this video, I will give you a demonstration of the adapter design pattern, which is a structural design pattern, and I'll be using C#. We start by creating an interface I call iTarget. iTarget is the interface expected by the client. It defines the main specific interface that the client uses. We require the getRequest method. Next, I want to create a class I call adaptee. Adaptee is a class that has a different interface and needs to be adapted. GetSpecificRequest returns the string specific request. Next, I will create an adapter. An adapter will make the adaptee interface compatible with the iTarget interface. We extend the adapter with the iTarget interface, which requires a getRequest method. So we use a code generator to create it. GetRequest is not implemented, so we throw an error message. At the top, we create a new adaptee. The adapter takes the adaptee. And with getRequest, we return the string, this is adaptee.getSpecificRequest. Now let's create a client class for our demo. The client class depends on the iTarget interface. It's unaware of the adaptee and adapter. We create a main method. We create a new adaptee and set the target to a new adapter, of which we pass in the adaptee. We write to the console, adaptee interface is incompatible with the client, but with the adapter, the client can call its method. And we write to the console, target.getRequest. Let's now go to our program.cs page. At the top, we note using example. We add new client and we call main and we get. Adaptee interface is incompatible with the client, but with the adapter, client can call its method. This is specific request. This example demonstrates how the adapter pattern can be used to integrate classes with incompatible interfaces. The client can be used the adaptee via the adapter without changing its code. My name is Ray, always code with a smile. SWOT analysis of the structural design pattern known as the adapter design pattern in C#. S. Strengths. Compatibility. Bridges incompatible interfaces, allowing legacy code integration with modern C# applications. Reusability. Increases code reuse by adapting existing functionality to meet new requirements. Encapsulation. Encapsulates conversion logic, keeping it safe from business logic. W. Weakness. Added complexity. Adds complexity when adapting simple interfaces, especially for small projects. Overhead. Runtime overhead may occur due to additional layers of indirection. Dependency risk. Over-reliance on adapters can lead to fragile dependencies in dynamic environments. O. Opportunities. Legacy systems. Enables integration of legacy systems into .NET environments. API bridging. Simplifies bridging third-party APIs with custom implementation in C#. Cross-team collaboration. Facilitates collaboration by allowing teams to work with preferred interfaces. T. Threats. Overuse. Excessive use can clutter code with adapters, reducing clarity. Confusion. Mismanagement of adapter roles may confuse developers during maintenance. Direct solutions. Simpler approaches might solve certain compatibility problems without needing adapters. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment and find me on all my social media platforms. But most of all, tell a friend the Ray Code is awesome.